For this example, we will have radioactive decay. We want to draw a direction field for radioactive decay, so Q prime equals negative K times Q. Here K is equal to 0.5, and we're assuming that Q at time t equals 0 is greater than 0, meaning there's some positive quantity of radioactive substance when you start your experiment at t equals 0. Alright, so let's go ahead and do that. So here I'll have Q of t. Here I'll put t. Alright, so first thing, we're going to completely ignore this because that would be negative mass. Which is unrealistic. So we're only going to focus on the direction field up here. So let's go and do this. Let's do 1, 2, 3, and let's start drawing the direction field. So if I just plug in the k value, this is Q prime is equal to negative 0.5 times Q. So then we're at Q starts out as 1, then Q prime is going to be negative 0.5 times 1. So a very slight slope. Let's see if I can do that. Something like that. I'll try my best. If we're at a half, then we'd actually have negative 0.5 times 0.5, so that would be, let's see, a quarter. So I gotta try and draw this even flatter, but slightly negative. Alright, let's try an easier one. If we plug in Q equals 2, then we get negative 0.5, so negative 1/2 times 2, so that's negative 1. So I think I can draw negative 1 fairly accurately. Alright, and then here, if I plug in 1.5, that's a little bit harder to calculate in my head, but I just know it's going to be between these two, so I'll try and draw a slope somewhat in between them. I'm not doing a great job. I did my best. If we're at 3, then we get negative 0.5, so negative 1/2 times 3, so negative 3/2, so a little bit steeper. I'll probably exaggerate this one. And then the slope in between, that's a little harder, that's 2.5 times 0.5. I'll just approximate it as something in between those two slopes, if I can. Right, so that's the slope field. And if we were to draw trajectories on that slope field, it kind of makes sense. So everything's going down, which makes sense because we want everything to decay. And if we waited a really, really, really long time, we would get almost 0 radioactive substance. And so all these things will do something like that. And if you start with more, decay faster, and so on, so forth. There we go. That's the direction field for a radioactive decay example.